Hey guys, this is a video on determining whether lines are parallel, perpendicular, or neither. We're going to do this using some things that we already know about slope. So for example, we know that parallel lines have the same slope, and we know that perpendicular lines have negative inverse slopes. So looking at example number 1, if I want to determine whether these lines are parallel, perpendicular, or neither, I need to be able to find their slopes. And in order to do that, I need to get my equations into slope-intercept form of the equation of the line. And just as a reminder, my equation of a line in slope-intercept form looks like y equals mx plus b, where m is my slope. Okay, so for number 1, getting our equation into slope-intercept form, we have to solve for y. So I'm going to start by rewriting my equation, and I'm going to write kind of small, and I'm going to write all the way on the edge of my paper to make sure it fits. So I have 2x plus 5y equals negative 9. Now if I want to get y by itself, I have to move that 2x, positive 2x, to the other side of the equation. Now remember from completing the square and circles, if I want to move a term from one side of the equation to the other, I'm essentially just changing its sign. So this positive 2x is going to become a negative 2x. I'll have 5y equals negative 2x minus 9. And then my final step to solve for y is to divide all of my terms by 5. Simplifying, I get y equals negative 2/5 x minus 9/5. And I want to also state my slope. My slope is the coefficient of x. It doesn't include x, it's just the number in front of x. In this case, my slope is negative 2/5. Now I'm going to go ahead and do the same for my other equation, which is 6x plus 15y equals 3. Same idea, I want to get y by itself, so I want to move this positive 6x to the other side of my equation. It's going to become a negative 6x. 15y equals negative 6x plus 3. Continuing to solve for y, I'm going to divide all of my terms by 15. And doing some simplification, I'm going to get y equals, and in my calculator, I can go ahead and type negative 6 divided by 15 to reduce that. And I'll get negative 2 over 5 x plus, and in my calculator again, 3 divided by 15 is 1 over 5. Okay, in this case my slope is negative 2/5 as well. Again, it's my coefficient of x. And now I just need to write my explanation. Because my slopes are the same slopes, then I have parallel lines. So my conclusion says the lines are parallel. All right? And that's the first example. Let's go ahead and take a look at number 2 as well. Once again, I'm going to start by rewriting my first equation. 3x minus 5y equals 10. In this example, notice that your y term is negative. Because it's negative and I want it to be positive, I'm going to take care of that in my first step. And in order to do that, I'm just going to change the sign of every single term in my equation. That's essentially the same thing, or what will happen if I multiply through by negative 1 to get my signs change. So my positive 3x is going to become a negative 3x. My negative 5y is going to become a positive 5y. And my positive 10 is going to become a negative 10. And then we're going to continue to solve. This negative 3x needs to be brought over to the other side of the equation, so it's going to become positive. I will have 5y equals 3x minus 10, and then I need to divide through by 5, every single term. I'm going to reduce, and I'll have y equals 3/5 x minus 10 divided by 5 is 2. In this case, my slope is equal to 3/5. All right. Final equation, I'm going to start by rewriting it. 5x plus 3y equals 7. In this case, my y term is already positive, so I'm good to go. I'm going to bring my positive 5x to the other side of the equation by making it negative. 3y equals negative 5x plus 7. I'm going to go ahead and divide through all of my terms by 3 and reduce. I'll have y equals negative 5/3 x plus 7/3. Here my slope is negative 5/3. So I have a slope of 3/5 and I have a slope of negative 5/3. Hopefully you will recognize that these are negative inverses, but we need to go ahead and show that on our paper. So as we did last unit, we're going to take our two slopes and multiply them together. Check it in our calculator and show that we get negative 1. Because they multiply to equal to negative 1, my slopes are negative inverses. If I have negative inverse slopes, then I have perpendicular lines, and my conclusion, the lines are perpendicular. And there's the second example. We have one more case that I'm not going to do an example of, but I do want to talk about what our explanation would look like. If we're going to prove that the lines are neither parallel nor perpendicular, then we need to show and explain that the slopes are not the same, which makes them not parallel, and they're not negative inverses, which makes them not perpendicular. So here's what our explanations should look like in the three cases. In number 1, we saw an example of proving that the lines are parallel. In number 2, we saw an example proving that the lines are perpendicular. The last case, this is what our explanation should look like. If the slopes are not the same, then the lines are not parallel. If the slopes are not negative inverses, the lines are not perpendicular. So therefore, our conclusion is that the lines are neither. Don't forget, when we're showing that the slopes are not negative inverses, we have to still multiply the slopes together and show that we do not get negative 1. And that's it.